Number 90 is a tough problem, and this is a concept that we continue to struggle with as we go through this unit here, guys. But honestly, I can't really be mad at you guys if you missed this particular problem right here. And it's because they gave you tough information and they gave it to you in a really difficult way. So we've got a table right here with values of h and h prime, and they're telling you this weird fact right here, guys. H of g of x, which is the composition of two functions, is equal to x. What they didn't tell you outright that they normally do in a problem like this is that if you do the composition of two functions and you get just plain x for the result, that means, everybody, that one function, in this case h of x, is the inverse of the other. That will happen anytime you do the composition of two functions and you get a result of x. It really means, guys, you take x for your starting value, put it into g, get some result from g, put it back into h, and you end up with the exact same number you started with. And so, now that we've talked about that, I'm hoping you guys recognize, all right, this is a derivative of an inverse problem, which we've still struggled with a decent amount throughout the course of the year. Now we're trying to find the value of g prime of 7, which means I'm going to put g of x over here on the right, and I'm going to put h of x over here on the left. And what we're eventually looking for, g prime of 7, is going to come from an ordered pair here on the right-hand side, where 7 is the x value in the g function. So this is going to be 7 comma something. But its sister point over here on the left then, well, that means that it's got 7 for its y coordinate, and we're trying to figure out what x is. Well, now it's about time to go to my table, because the table, you'll notice, has nothing to do with g. The table is all about x. And what am I reading right here, guys? That when x is equal to 3, h of 3 then is going to equal 7. That tells me the x value I'm missing right here is 3. It also tells me this y value over here on the right, on g, is 3 also, but that usually is irrelevant in a problem like this. Now, what would we do next? Very often we would find a general definition for h prime of x, but we can't do that here because they didn't explicitly define what h of x was. But the reason we would find the general derivative is to evaluate h prime at this value right here. And the table tells us that value. H prime of 3 is right there, guys, and it's equal to 5. And if these two functions are inverses of one another, here's how we can get around not knowing, well, geez, we don't know h, we don't know h prime, we don't know g, and we can't find g prime, but we do know then that the derivative of g, which is the inverse of h, not evaluated at 3, but at this value right here, g prime of 7, is just going to be the reciprocal of this number right over here. So 1/5, that being the reciprocal of 5, is the answer we were looking for. Number 90 is C.